Hi, my name is Andres, and I'm going to explain activity 6, interacting with the analog world using a microcontroller. In this case, we're going to use PIC 16FA 77A PIC, and we are going to, as well as we have been doing in the previous programs, we're going to set our frequency crystal to high speed to be because we're going to be using a frequency crystal oscillator of 20 megahertz, and we define this port for the LEDs 1 and 2 that are going to be the LEDs are going to be toggling, and we set a toggle constant in order for us to control the time for the toggling of the LEDs. We declare a double variable because we want to need numbers with decimal values and an int variable in order for us to change between cases that we're going to see. Next. First of all, we're going to declare our we're going to initialize our ports. We're going to use port B as an output, port C as output, and port D as output, and we set 0 to these ports. We create this function, and it's going to be called in the switch case. This function is for the LEDs to toggle for a period in a period of the time set. In this case 200 milliseconds, and they will turn on and turn off alternately. Toggling each 300 milliseconds. Moving to the main, or to the next one, or to the next subroutine. This routine is for us to initialize our port A to be to activate the analog digital converter to convert the analog reading of our input of our solar panel in digital values. We're going to set this frequency or the time for each one of the conversions to be the frequency of the crystal or oscillator of our divided by 16. This is going to be the time that it would take for each one of the calculation or for each one of the conversions from analog to digital. And in this case, we're going to refer to internal reference voltage. In this case, it's going to be 5 volts because our solar panel is 5 volts, and it allows us to convert more equal or more directly from 0 to 5 volts, and not require any other voltage that is or any reference voltage. We're going to lay 100 milliseconds, and then we're going to move to the void that calculates the value of the digital value of our input. We declare go down to 1 to initialize the analog to digital conversion. While this is on, we're going to wait for it for the conversion to finish, and in an int variable we're going to storage the bits the bits that are going to be returned from our input, the first 8 and the rest of the 2, because there are 10 bits. And in order for us to calculate the amount of voltage that we are receiving from the solar panel, we're going to make a conversion that is 5 volts divided by 1023, because those are the bits that we're using, and it gives us this number. So every bit that this the amount of bits that it is storage or it reads are going to be multiplied by this variable, or by this constant, and it will give us the voltage that we're receiving. So in the main, we initialize the ports, we initialize the analog, the analog ports, and then we choose the channel. The channel that we are going to be using is the analog channel 0. That is the first one of the analog. And we set this to 0 because this is the one that is going to be selecting our channel. If it's 0, 0, 0, it's channel 0. If it's 0, 0, 1, it's channel 1, and respectively using the binary code. Now, we call the subroutine calculate because we will need the digital value. And if the lum or the variable is between 0 and 2.5 volts, it would be 0. If it reaches a level of voltage greater than 0.5 but lower than 1, it will send a 1, and it will continue every 0.5 volts, sending a 2 and calling this subroutine. This subroutine activates a switch case depending on the value of the variable I. It will switch between cases. In the case of 0, it will not display anything in the bar LED. It will not display anything in the port D because this port D is connected also to the 10 bar LED. And in port C, it will declare a low state or a low luminosity or low voltage in the input. And it will toggle the LEDs indicating that the level of the light is low. In the case of 1, it's going to turn on one of the LEDs of the bar, and it will remain this as 0 because we're not using, we're not yet using those LEDs. And it will also tell us that it's low, and it will toggle, and we continue toggling the LEDs. For the case 4, and if we see the case 4, it indicates that it's higher than 2, but lower than 2.5, that it never reaches this value. We're going to set this variable to 4. We're going to call this routine, and in this routine, it changes. We have 4 LEDs on, and we can see that it will send us a high in the 7-segment display. It will send us a high, and it will be increasing the amount of LEDs as the amount of voltage or the value of the voltage is increasing. It will increase the amount of LEDs that we turn on. At the end, all LEDs will be turned on if it reaches 5 volts. And in port C, it will be declared that it's a high state or it's high luminosity. Now we're going to be seeing this working in Proteus simulation. As we can see in this Proteus simulation, we're going to set this value to 0. We can see that this value is 0, and the LEDs are toggling because it's indicating that it's a low luminosity. There is not enough light in the room or in the area. And if we increase this value, we're going to see that it turns on the first LED, the second one, the third one, and when it reaches a voltage level higher than 2.5 or it's equal to 2.5, it will send us, it will indicate us that it's a high level or it's enough light in the area, and the LEDs will stop toggling. If we decrease the value, the LEDs start toggling again and indicate us that it's a low value. So if we keep increasing, it will tell us that it's enough light or it's a high state. And if we keep increasing, this never reaches 5 volts. That's why it only turns on 9 LEDs. And we can see here that the program works as expected.
Here we have Here we have a program implemented in physical hardware. We have all port B and 2 pins for port D connected to the 10-bar LED. We have the port C connected to the 7-segment display, and only 2 pins from port D connected to the toggle LEDs. Now we see here that we have a low level of voltage. It reaches 1, 1.5 maybe, and a 0.5. So it's telling us that it is a low amount of voltage. If we decrease lower, we have 0 voltage maybe. And if increases, if we increase this amount of voltage here, if we increase it, we can see that it tells us that it's high. If we increase this voltage, it tells us that it's high. So because the luminosity in the area, it's high, it's enough for the area, for environment. So if we take away this, we will see how it decreases the level. We can see that it works perfectly because it tells us when the light is. We can see that, and it's lower than 2. It reaches higher than 2 because the light is turned on, but it not only means that it's higher than 2.5. It needs to be higher than 2.5. So we see it works correctly.